Hello viewers! Last week I built the first prototype of Vi's new hand. If you haven't seen that video yet, I highly recommend watching it first. The results were promising, but it wasn't quite there yet. So before moving on, I decided to focus on fixing one major issue. And that issue was friction. The fingers could move a little bit at first, but then they would eventually stop completely. You might ask, if friction is the problem, how could it move at all in the beginning? Here's why. There are three main factors at play: the servo torque, the friction in the hand, and the pullback system, which in my case is rubber bands. The pullback system needs to be strong enough to pull the string back enough through friction. But at the same time, the servo has to be strong enough to pull the string forward against both friction and the pullback force. So the question becomes, what should I optimize? Since the pullback force always has to be greater than friction, and the servo has to overcome both, the most effective solution is to reduce friction as much as possible. So where was the friction coming from? In my system it mainly came from three places: the wrist wheels rotating around their axis, the small reorienting bars that guide the string, and the finger bones when the finger bends. That last one explains why the fingers could move at first, but not fully, because friction increases as the finger bends and the rubber bands pull harder at higher angles. At first, it was hard to pinpoint exactly what caused the most friction, but after some research I learned about something called capstan friction. This happens when a string slides over a stationary surface and the friction increases exponentially compared to a rolling surface like a wheel. In my design, capstan friction occurred in two main places: the reorienting bars and the finger bones. So my first thought was, why not replace those contact points with wheels? I tried that, but small wheels introduce another problem. If the string tension isn't high enough, the string can easily jump off the wheel and slide back onto the bar. That's less of an issue with large wheels that have sidewalls, but much harder with small ones. Even when the string stayed on the wheel, the friction was still too high. Then I noticed something I should have caught earlier. Some of the wrist wheels weren't rotating at all. Specifically, the little finger. Its wheel sits lower than the others, and when it's slightly pushed downward, it creates a side friction that stops the wheel from spinning. At that point, the wheel effectively turns back into capstan friction. Luckily, this had a simple fix. I added a clearance ring. After that, the friction dropped low enough for the pullback system to actually work. However, at extreme angles the fingers still struggled. So I decided to switch all the finger servos from normal servos to standard servos. And that finally solved it. Next I moved on to the thumb. The reason I didn't test it last week was because of a miscalculation in the thumb knuckle joint which prevented rotation. I fixed that by adjusting the hold position and adding a blocker underneath to prevent over-rotation. And here's the thumb test. It's still not perfect, but this is a big step forward. I'll keep improving it and see where it goes. And subscribe if you want more videos like this. Anyways, see ya!